We're now going to look at using integration to find the area of a shape that is not necessarily bounded by the x-axis. So here we've got the area of a curve bounded by the line y equals x. Now previously, in last lesson, we were integrating from one point to another to find the area of the shape of the curve bounded by the x-axis. So if we were to integrate from this point here to that point there, integrating the curve y equals x 4 minus x, we would get this shaded area, but we would also get all of the area underneath y equals x that's bounded by the x-axis. Now if you look at this pink shape that I've just drawn, that is actually a right angled triangle. We can integrate the curve from this point here to that point there to get the whole area and then just subtract that pink area. So in order to do this, we need to find out what the x value is at the point where those two lines intersect. So we're going to solve the simultaneous equations where y equals x and y equals x 4 minus x. So if I call that equation 1 and this equation 2, I'm going to substitute equation 1 into equation 2. So I'm just replacing y with x. And I get that x equals x multiplied by 4 minus x. If I expand that bracket, I get that x equals 4x subtract x squared. If I then rearrange this, first of all adding x squared, I get that x squared add x equals 3. Equals 4x there. If I then subtract 4x from each side, I get x squared subtract 3x equals 0. I can factorise this to solve it, to get x multiplied by x minus 3 equals 0. So that those two lines intersect when x equals 0 or when x equals 3. So this value here must be where x equals 3. I'm going to integrate my curve from 0 to 3, and I'm going to subtract the area of the pink triangle. So looking at that pink triangle, I've got a width of 3, but I don't know what the height is. Now I know that x is equal to 3, and I know that the point here lies on y equals x. So when x equals 3, y must equal 3. So I know I've got a height of 3. So to find the area of the triangle, I'm doing a half times base times height. That should say dx there. So I'm going to subtract that area from that integral. So I'm going to start by expanding this bracket here so that I can integrate term by term. And I'm going to work out what this bracket is equal to here. So a half times 3 times 3, that is 9 over 2. So I'm going to integrate this expression. So I've got 4 over 2 x squared minus 1 over 3 x to the power of 3 from 0 to 3, and I'm subtracting 9 over 2. So I'm going to first of all substitute in x equals 3. So I've got 4 over 2. When x equals 3, x squared is 9. And I'm subtracting a third. When x equals 3, x cubed is 27. I would then subtract the value of my expression when x equals 0. Each term of the expression has an x in it. So we're going to end up subtracting 0 and then subtracting 9 over 2. Now 4 halves times 9, subtract a third times 27. That is equal to 9. And I'm subtracting 9 over 2 from 9. And my answer is 9 over 2.